Morning, students. Mr. Carver here. Section 3.9, Differential Approximation. This is just a quick introduction to the types of things that you're going to be seeing, the measurements you're going to be using, and just how Chapter 2 ties in with Chapter 3. All right, let's take a look at this picture. And if you think back to Chapter 2, when we first started talking about derivatives, remember derivatives are really nothing more than slope machines. And the slope machine will allow us to calculate the slope of a curved line at an individual point. So if I take a look at this red curve right here that you're seeing, and I want to approximate the slope right here at A, you can see that this green line gives me the slope of the red curve right at A, and we're going to call that slope dy over dx, just like we always do when we talk about the slope machine, right? Because that is f prime. And f prime is a slope machine, dy over dx. All right, now it doesn't matter what 2 points on the green line we pick, I will still get that same slope. That's the way straight lines work. So this, if I pick this point right here, and I'm picking that point for a reason, I think you would agree that this then, that distance right there, is dx, and this distance right here is dy. The slope is change in y over change in x. That's dy over dx. Now if I go all the way up here, if I approximate it by using the blue curve, which is what we did back in the day, remember we started off by getting really poor approximations by picking 2 points on the curve that were close together, finitely close together. For instance, if I was looking for the slope at like 0.5, I may have picked 0.6, something like that. So according to this picture, now this picture, this distance along the x-axis from here to here was delta x, right before we found out what a derivative was. And this distance along the y, going from here up to here, is delta y. Now, according to this picture, dx and delta x are exactly the same, but dy and delta y are wildly different, right? Here's your dy here, and here's your delta y right there. So this is going to give you a horrible approximation of the slope because your delta y is so far off. So what we did was, back in Chapter 2, is we started moving point Q closer to point A. We started picking points that were really, really close together, and the closer Q got to A, the better the approximation of the slope of the green line, right? The blue line had a closer slope to the green line. So let's take a look at that picture. And here's what that looks like. So again, if I look at my x-axis from here to here, it's going to be dx. From here to here is going to be dy. And if I look at Q and A, this distance is written blue. From here to here is delta x. You can see delta x and dx are exactly the same. Now, this is delta y. And as you can see, the closer Q and A get together, the closer delta y is to dy. So if I were to calculate the slope of the green line and calculate the slope of the blue line, they would still be different, but the blue line slope would be closer to what I'm looking for. That is the slope of the green line. And so what I want to do is I want to take point Q and move it even closer to A. Let's take a look at what that looks like. So now I've got Q and A right up against each other, and my delta x, while they are the same for the red and the blue, my delta y and my dy are so close you can barely tell the difference between the two, which is why the slope of the blue line is so close to the slope of the green line. Now, in this section, dy over dx is going to be really close to delta y over delta x. This is a really important arrangement, and these problems are picked so that that is true in every single problem. That'll also be true on the quiz that I give you. You can just think of delta y over delta x as being represented by dy over dx. They are essentially the same quantity. And that's what this section's all about. All right, I'd like you to go and look at the other Section 3.9 video, and it'll walk you through how to do these problems in this section. Thank you.